Hi everyone, it's Chris Magwood here from the Endeavour Centre, the Sustainable Building School in Peterborough. A lot of the work that I've been doing here at Endeavour is about how buildings impact climate change and what we can do about it. As the realities of climate change start to really set in, the building industry is realizing that it's responsible for a lot of human-caused emissions on the planet. Some of those emissions are from operating buildings, and those we've known about for a long time. But there's another side to buildings and climate change that hasn't been getting much notice until very recently, and that's called embodied carbon. So what does embodied carbon mean? Embodied carbon is the emissions footprint that comes from harvesting, transporting, and manufacturing building materials. Each stage in the process of getting a building material to a construction site causes greenhouse gas emissions. And this carbon footprint from materials can be very significant. It's up to 11% of all human-caused emissions on the planet. Since the embodied carbon of building materials is so significant, it's important that we learn how to work with these numbers and come up with accurate ones. We need to do the basic accounting of how much embodied carbon is associated with each material, and then how much embodied carbon footprint an entire building will have if we're going to be able to reduce it. To understand embodied carbon, we need data. This data comes from studies called life cycle assessments, or LCAs, which look at all phases of a material's lifespan and add up all the carbon emissions that happen. In this case, we're looking at cradle-to-gate emissions, a total of all the greenhouse gases released during harvesting, transportation, and manufacturing of the material. Once we know the cradle-to-gate emissions of each material in our building, we can add up the sum total of all those emissions and get a sense of the carbon footprint for making one particular building. For a long time, it's been difficult to access LCAs, and so that's made it hard for somebody to figure out what the carbon footprint of a particular building might be. But now, there's a report called an Environmental Product Declaration, or EPD, in which companies show the life cycle assessments of their products. These EPDs are conducted according to a set of international rules and usually carried out by a third party to verify the information. In an EPD, the embodied carbon is expressed as the global warming potential, or GWP factor, for a given amount of a specific material. You can multiply the amount of material you are using by its GWP factor and figure out what the carbon emissions for each material in your building will be. This kind of embodied carbon analysis can give us a really good sense of which materials have a high embodied carbon and which ones we might be able to replace them with a lower embodied carbon. If we make the right choices, we can have a dramatic impact on the climate change effects of any given building. As an example, let's look at a model of a 10,000 square foot, 4-story, 8-unit residential building. If we choose common building materials that have a really high carbon footprint in their category, this building could be responsible for as much as 207 tons of greenhouse gas emissions before anybody's even moved in. This is a huge carbon footprint. We could also choose a less intensive set of materials and get that figure down to 110 tons of emissions. This is still high, but through those simple material substitutions, we've almost cut the carbon footprint in half. But we could make even better choices using commonly available code-compliant materials and get the carbon footprint down so that our building actually now stores 10 tons of carbon and has no net emissions. This is a real zero-carbon building. By using the best possible material selections, we can see this same building storing 125 tons of carbon. This is a real carbon drawdown building.
How is it possible for a building to store more carbon than it emits? It seems counterintuitive. Carbon-storing buildings use a relatively high proportion of plant-based building materials. During photosynthesis, plants capture gaseous carbon from the atmosphere, and that carbon becomes a high percentage of the plant's mass. When we harvest those plants, the carbon stored in them is taken out of the carbon cycle for as long as they're contained in the building. The amount of carbon stored in the material can be significantly higher than the emissions created to harvest and produce the material. This provides us with an effective means of drawing carbon out of the atmosphere and keeping it out for a relatively long period of time. By focusing on using agricultural residues and waste stream fibers, we open up a whole new paradigm. Building materials with carbon drawdown and storage potential. We can use enough of these carbon storing materials to offset the emissions from other materials in the building and achieve net zero or even net positive carbon footprint for a building.
With informed decisions about the embodied carbon impact of the materials we're choosing, we can have a huge impact on climate change in our buildings. We can substitute low carbon materials for high carbon materials. A builder or a homeowner can have a massive effect on the climate change impact of their building. In fact, it's one of the biggest impacts we can make to change our current climate trajectory. And that's true for new buildings, renovations, at any size and any scale. I encourage you to think about the embodied carbon of the materials you're choosing for your next building project. The impact that you can make on climate change is real and it's significant. Thanks for watching. I hope you enjoyed this video. If you'd like to learn more about embodied carbon or sustainable building in general, watch for more videos from Endeavour or check out our website.